I'm Shalini, we working as Assistant Professor of Physics. In this video, I will discuss the topic for the session 35 for B.Sc first semester. The topic of this session is stress strain diagram, elastic limit and Hooke's law. So before going to discuss the topic, we have to know what is elasticity, what are perfectly elastic and perfectly plastic bodies. So elasticity, it is the property of a material to regain its original condition on the removal of the deforming forces. Then the bodies which can recover completely their original condition on the removal of the deforming forces are called as perfectly elastic bodies, and the bodies which do not show any tendency to recover their original condition are called as perfectly plastic bodies. So there are no perfectly elastic or plastic bodies. Then what is a stress? So stress is the deforming force acting on a body per unit area of the surface. If F is the force acting on a body of surface area A, then stress is given by force divided by area. So the SI unit of stress is Newton per meter square and its dimensions are ml minus 1 t minus 2. Then there are three different types of stress are there, depending upon the direction on which the force acts. They are longitudinal or tensile, tangential and normal or bulk stress. So if the force is acting along the length of the body, the stress is called as a longitudinal or tensile stress. If the force acts tangential to the surface of a body, the stress is called as shearing stress. And if the force acts normal to the surface of the body, the stress is called as normal or bulk stress. Then we have to know what is a strain. So when a system of forces acting on a body produces a change in shape or size or both of the body, the change is called the deformation of the body. Then the ratio of change in length or size or shape to the original value is called as strain. Strain, it is a dimensionless quantity having no unit. Then again, depending on the type of a stress, there are three types of strain. So first one is a longitudinal strain, and it is the ratio of very small change in length dl produced due to the longitudinal stress to the original length. So longitudinal strain, it is a ratio of a change in length dl to the original length l. So longitudinal strain is equal to dl by l. Then second type of a strain is a shearing strain. So it is defined as the small angular displacement of a reference line on the surface of which tangential stress is acting. Shearing strain is denoted by theta and it is equal to x by h. Then third type of a strain is a bulk strain. So it is defined as the ratio of a small change in volume dV to the original volume V of a body on which the normal forces are acting. So bulk strain is equal to change in volume dV divided by the original volume V. Then what is an elastic limit? So it is found experimentally that for many substances, the strain produced by a stress is directly proportional to the stress. So when the stress is gradually increased, a stage is reached where the linear relationship between stress and strain is no more valid. That is, stress is not proportional to strain. This maximum value of stress above which the linear relationship between stress and strain ceases to be valid is termed as the elastic limit of the material under consideration for that particular type of stress applied. Then what is a Hooke's law? So Hooke's law states that within an elastic limit, stress is proportional to strain. That is, stress is directly proportional to strain within the elastic limit, or stress divided by strain is a constant, and that constant is called as coefficient of elasticity or modulus of elasticity, and it depends upon the material of the body. So the dimensions of coefficient of viscosity elasticity or modulus of elasticity is ml minus 1 t minus 2 and its unit is Newton per meter square. Then what is a stress strain diagram? So when a wire is gradually loaded and if the extension produced in each case is plotted against the load, the obtained graph is called as a stress strain diagram. So the load uh, uh, mm, applied to a wire is nothing but the stress which is taken along the y-axis, and the that is the elongation which is produced, that is the strain, is taken along the x-axis, and a stress against a strain graph is called as a stress strain diagram. So this is the stress strain diagram here. So all along the path OA, so the obtained path, it is a straight line. The extension is, that is the stress, is proportional to strain. So all along the path OA, the stress is proportional to strain. So with the increase in stress, the strain also increases and the wire obeys Hooke's law. So in this range, in this range from 0 O to A, the when the load is removed, OA is perfectly elastic range and A is the elastic limit. So in this range, if the wire regains its original condition when the load is removed, that therefore OA is called as the perfectly elastic range and A is called as the elastic limit. Then if the wire is loaded beyond OA, so if the wire is loaded beyond OA, the extension is no longer proportional to the load and Hooke's law is not obeyed. That is, above the OA, if a load is applied, the extent, that is the stress, is not proportional to strain above OA. That means that it does not obey Hooke's law above OA. So, and here, if when the load is removed, the wire will not regain its original length, but a permanent elongation will be there in it. And at the point B, even any small amount of addition of a load to the wire causes enormous elongation. So, hence this point B is called as the yield point. So, the point B is called as the yield point. So after this yield point, the extension increases very rapidly and depends on the time for which load acts. The specimen exhibits the phenomena known as a necking, that is, as the extension of the wire goes on increasing, the area of cross section decreases until the breaking point is reached and finally the wire breaks. The load at which the wire breaks is known as the breaking load. The breaking load divided by the original cross-sectional area is called as the breaking stress. So it is also known as the ultimate strength or tensile strength of the material which is under consideration. So this is all about the stress strain diagram. These are the books which I have referred. Thank you.